Hello everyone. So today we are going to learn about fluorimetry and its instrumental methods of applications. So, what is fluorimetry? Fluorimetry is a scientific and analytical technique used to detect and measure the fluorescent light emitted by the sample lying in the visible spectrum with the aid of ultraviolet rays. Here, the wavelength of the emitted light by the substance is greater than the absorbed light. This phenomenon is called luminescence. In luminescence, light is produced at low temperatures, hence, the light produced is called cold light or light without heat. With the measurement of intensity along with the wavelength of the emitted fluorescence, the properties and composition of the sample can be studied. Principle of fluorimetry. Molecules contain sigma electrons, pi electrons and non-bonding electrons. Electrons may be present in the binding molecular orbital. It is called the highest occupied molecular orbital. It has least energy and is more stable. When molecules absorb radiant energy from light source, bonding electrons may be promoted to antibonding molecular orbital. Antibonding molecular orbital has more energy and hence are least stable. Due to this change, electron reaches from ground state to excited state. After reaching excited state, it shows kind of illuminating property which is called as fluorescence. It occurs due to radiations emitted by electron at excited state. States of electrons in fluorimetry. First, singlet state. Singlet state is a set of particles whose net angular momentum is zero, that is, whose overall spin quantum number. As a result, there is only one spectral line of a singlet state. Second, doublet state. Doublet state is a composite quantum state of a system with an effective spin of 1 by 2 such that there are two allowed values of the spin component, that is minus 1 by 2 and plus 1 by 2. Third, triplet state. Triplet state is an electronic state in which two electrons in different molecular orbitals have parallel spins. Phosphorescence. Phosphorescence is a type of photoluminescence similar to fluorescence, but the key difference is it continues to emit light even after the excitation source is removed. How it works. Energy absorption. When the phosphorescent materials absorb light, usually ultraviolet, its electrons are excited to a higher energy state. Delayed emission. Unlike fluorescence, where the light is emitted almost immediately, phosphorescent materials release the absorbed energy slowly. So, here we can see the electronic moment in fluorimetry. So, first the electrons move from the ground state to the singlet excited state, which is called as the excitation. And when the electron moves from the singlet excited state to the ground state, we get fluorescence. So, let us see the instrumentation of fluorescence. The key components are first, source of light, second, filters and monochromators, third, sample cells, and fourth, detectors. Sources of light. First, mercury vapor lamp. A mercury vapor lamp is a kind of gas discharge lamp. It makes light from mercury. The mercury atoms release ultraviolet and visible light. In some bulbs, the ultraviolet light shines on phosphors which make white light from it. Second, xenon arc lamp. A xenon arc lamp is a highly specialized type of gas discharge lamp, an electric light that produces light by passing electricity through ionized xenon gas at a high pressure. Third, tungsten lamp. In an incandescent lamp consisting of a tungsten filament sealed in a compact transparent envelope that is filled with a mixture of an inert gas and a small amount of halogen such as iodine or bromine. Filters and monochromators. Filters. Optical filters work on principle of absorption of unwanted light and transmitting required wavelength of light. In inexpensive instruments, fluorimeter, primary and secondary filters are present. Primary filters. absorb visible radiation and transmit UV radiation. Secondary filters absorb UV radiation and transmit visible radiation. Monochromators. Monochromators can convert polychromatic light into monochromatic light. They can isolate a specific range of wavelength or particular wavelength of radiation from source. There are two types of monochromators. First, excitation monochromators provide suitable radiation for excitation of molecules. Second, emission monochromators isolate only radiation emitted by fluorescent molecules.
In a flourimeter, sample cells or cuvettes are used to hold the samples during fluorescence measurement. Some key characteristics of sample cells are material of sample cells is quartz or optical glass, which allow UV visible light to pass through without absorbing it. Standard path lengths are usually 1 centimeter, but shorter or longer options can be used depending on the concentration of the sample. Shape generally rectangular or square with specific designs to minimize light scattering and enhance measurement accuracy. Volume can vary with common sizes ranging from 1 ml to 3 ml. Many are designed to be easily cleaned and reused, though some may be disposable, especially for sensitive or hazardous samples. Then we have detectors. In detectors, what is the function of detector? So, uh, detectors detect the intensity of the photon. So, the two photon excitation light is generated by increasing the photon density using a focused high power femtosecond pulse laser. Fluorescence emitted from the focus point is detected by a point detector and fluorescence image is acquired by LSM. Examples of detectors, commonly used detectors are photovoltaic cells, photomultiplier tube. So in photovoltaic cells, they consist of a silver or thin layer of gold coated metallic film that acts as an electrode. Consists of two electrodes. Both layers are separated by the layer of selenium acting as a semiconductor. Falling of UV rays on the selenium layer mobilizes the electrons which are taken up by the metallic electrodes, creating a potential difference and hence resulting in the flow of electrons. We can see the diagram. Photoelectric cathode is present. Incoming light wire anode. Electron emission is from the middle. Flow of current is detected through the galvanometer, where the current is directly proportional to the intensity and wavelength of light falling on it. Then we have photomultiplier tubes. Photomultiplier tubes are extremely sensitive detectors of light in the ultraviolet, visible, and in near infrared ranges of electromagnetic spectrum. They are members of the class of vacuum tubes, more specifically vacuum phototubes. These detectors multiply the current produced by incident light by as much as 100 million times. These detectors are sensitive. Then we have instruments. There are three types of instruments used for measurement of fluorescence. Single beam flourimeter, double beam flourimeter, spectroflourimeter. Single beam flourimeter. In single beam flourimeter, we have light source typically uses a xenon lamp or LED to emit light at specific excitation wavelength. Excitation monochromator. This component selects the desired wavelength of light from the source before it is directed at the sample. Sample chamber holds the sample in a cuvette, allowing the excitation light to pass through it. Fluorescence collection. After excitation, emitted light from the sample is collected. The system usually employs a lens or optical fiber to focus this light. Emission monochromator. Similar to the excitation monochromator, this part filters the emitted light to select specific wavelengths for detection. Detector, commonly a photomultiplier tube, PMT, or a photodiode, which converts the collected light into electrical signal for measurement. The data processing system. The system includes software to analyze the emitted fluorescence, often providing quantitative data on sample concentration or properties. We have advantages of single beam flourimeters, easier to operate than more complex systems, making it suitable for routine analysis. Cost effectiveness, generally less expensive than dual beam systems. Overall, single beam flourimeters are widely used in laboratories for various applications, including environmental monitoring, biochemistry, and clinical diagnostics. Now, we have double beam flourimeter. A double beam flourimeter is a sophisticated instrument used to measure fluorescence by utilizing two separate light pathways. So, we will see the components. There is a light source, typically a xenon lamp or LED that emits light across the range of wavelengths. Excitation monochromators. Two monochromators select specific wavelengths, one for sample beam and one for the reference beam. Then sample chamber holds the sample in a cuvette, allowing for the excitation light to interact with the sample. Reference chamber contains a reference solution that provides a baseline measurement, often using a blank or a standard. Fluorescence collection. After excitation, emitted light is collected from both the sample and reference chamber. We can see that all the components of double beam and single beam flourimeter are almost same, as in double beam flourimeter, excitation monochromators are two, one for the sample beam and one for the reference beam. Then in double beam flourimeter, we can see that there is emission monochromator, filters the emitted light from both beams and select specific wavelengths for detection. Then we have detectors. Detector is also same like photomultiplier tubes. And then data processing system. Advantages of double beam flourimeter are increased accuracy. By comparing the sample's fluorescence to a reference, it minimizes effects of fluctuation in light intensity and detector sensitivity, leading to more reliable results. Better sensitivity, more effective at detecting low concentrations of fluorescent compounds. Enhanced dynamic range, can handle a wide range of sample concentrations without losing accuracy. Applications of double beam flourimeter. Biochemistry, analyzing proteins and nucleic acids. Environmental science, monitoring pollutants. Clinical diagnostics, measuring biomolecules and metabolites. Overall, the double beam flourimeter is a powerful tool for quantitative fluorescence analysis, providing more consistent and precise measurements than single beam systems. Now, there is spectroflourimeter. It is an advanced analytical instrument used to measure the fluorescence emitted by a sample upon excitation with light. Components are light source. So we know that light source used in fluorimeters are xenon lamp or LED, which provides broad spectrum of excitation wavelengths. Then we have excitation monochromator. Select specific wavelengths from the light source to excite the sample. Then sample chamber holds the sample in a cuvette, allowing the excitation light to pass through it and interact with the sample. Then fluorescence collection system, emission monochromator, detector, and data processing system. Software analyzes the fluorescence intensity and provides quantitative and qualitative data, including emission spectra. So the features of spectroflourimeter are spectral analysis, that is capable of measuring the fluorescence spectrum across the range of wavelengths, allowing for detailed characterization of fluorescent compounds. Then sensitivity and resolution provides high sensitivity and resolution, making it suitable for detecting low concentrations of fluorescent molecules. Versatility can analyze a wide variety of samples, including biological, environmental, and chemical substances. Applications of spectroflourimeter: biochemistry, studying protein ligand interactions, enzyme activities, and nucleic acid analysis. Environmental monitoring, detecting pollutants and contaminants in water and soil. Clinical diagnostics, measuring biomolecules, drugs, and metabolites in clinical samples. Spectroflurimeters are essential tools in research and industry for their ability to provide detailed information about the fluorescent properties of substances, enabling a wide range of applications across the various fields. Now we will see overall applications of the fluorimeter. Determination of uranium in salts used extensively in field of nuclear research. Estimation of traces of boron in steel by means of complex formed with benzene. Estimation of calcium by fluorimetry with a calcium solution. Determination of vitamin B, B1 thiamine, B2 riboflavin in the food samples like meat, cereals, etc. Fluorimetry is employed to carry out both qualitative and quantitative analysis for various aromatic compounds present in cigarette smoke, air pollutant concentrates, and automobile extracts. Thank you all for listening.